So what we want to do here is we want to tell the domain of a function. In order for us to tell the domain of functions, we have to know the two things that cause restrictions on functions. So there are two restrictions on functions. The first thing is you can't have a what in the denominator?
Zero.
No zeros in the denominator. So if I have a zero in the denominator, that's what? Bad, right? If I have a zero in the denominator, it causes me to have an undefined. Okay? The second restriction is I can't have a negative under the what?
Radical.
Yep, I can't have the negative under an even radical, like a square root or a fourth root. Okay, that's also what? Bad. Those are the two things we're looking for when we're calculating our domain. Domain means what number can I put in for x and actually get an output. Okay? What number can I put in for x and actually get an output? Now, if you look at this function, what numbers, if I put them in for x, will I not get an output? So let's calculate what f of 4 is. So f of 4 means 4 plus 1 over 4 plus 1 times 4 minus 2. So I need y'all to calculate what f of 4 is. And so on top, you have 4 plus 1, which is 5. And you have 4 plus 1 is 5 times 4 minus 2 is 2. So you get 10. And so that's 1/2. And so what was my input into that function? 4. I put 4 into the function. And what was my output? I successfully got an output, didn't I? Can you think of a number that if I plug that number into this function, I will not successfully get an output? Okay, so let's think about, let's say I tried to plug 2 into this function. Let's say I wanted to calculate f of 2. So f of 2 plus 1 over 2 plus 1 times 2 minus 2. And so f of 2 would equal 3 over 3 times 0, which is 3 divided by 0, which is undefined. Right? So I had an input. My input was 2. But that 2, when I put it in, didn't provide me with an output. So there's a restriction on my equation. I cannot plug what into this equation? 2. Now, if I plug -1 in, I also get what in the denominator? 0. Yeah, because -1 plus 1 is 0. So our restriction in this case is x cannot be -1. This right here means x cannot be -1. And x cannot also be what? 2. That's your domain. You're saying x can be, this little weird e means it can be all real numbers. This weird r means all real numbers. Okay? So x can be all real numbers, except for x cannot equal -1, and x cannot equal 2. So this is your domain. You're saying I can plug any number in for x that I want and also get an output. Except for, so that's what this is saying. I can plug any number in for x. X can be any real number. This weird r means any real number. X can be any real number except for the only two x's I can't have are -1 and positive what? If I plug -1 in, I don't get an output. And if I plug positive 2 in, I don't get an output. So this right here is your domain, what I have in this box. This is your domain. So now we need to look and see if that's one of the choices. Do y'all see that as a choice? Which one? Right here. See, it's saying x can be all real numbers, except x cannot be -1 and x cannot be 2. Okay, so let's look at this problem. Now, do I have a denominator here? What's a denominator? A denominator is the bottom of a fraction. Say it.
Bottom of a fraction.
I don't have a denominator here, so there's no way I can get 0 in the denominator. But what's the other restriction? I told you there's only two, 0 in the denominator and negative on the square root. This has a square root, so I could get something that's undefined. So let's say I wanted to calculate, all right, what is f of 2? That means the square root of 2 minus 3, right? And so f of 2, my input's 2, would be the square root of negative 1. Well, what is the square root of negative 1? Right, type it in your calculator. Type square root of negative 1, see what you get out.
Error.
It says an error. So when our input is negative 2, there is no output. Right? So what we need to do to tell the domain is we need to kind of express all these say, this says x can be all real numbers, x can be all real numbers, x can be all real numbers, x can be all real numbers. The second part is telling you what x can't be. This is saying x cannot be 3. Is that right?
No.
Well, let's do it. Let's calculate f of 3. F of 3 is the square root of 3 minus 3,
0.
which is the square root of 0. And what's the square root of 0?
0.
So when I put 3 in, I get 0 out. Well, heck, that's okay to plug in. For you to be able to tell whether or not you can get something out, you just plug it in and see what your output is. Is 0 an output? Is 0 an output? So we're good, right? So this is not the answer, this first one. Because it's saying x can't be 3, and we just showed that x could be 3, didn't we? So let's look at the second part. This is saying you can't plug anything in between negative 3 and positive 3. Right? Well, we just said that's false. Because there are numbers smaller or bigger that you might could. Okay? But let's think about this. So what number can I not plug? Can you think of the first number I can't plug in? Well, here's how you can solve this. We know that x minus 3 must be bigger than or equal to what? 0. Okay? Because 0 is the smallest number I can have under the radical, right? I can take the square root of 0, and I can take the square root of anything bigger than 0, right? But I can't take the square root of anything smaller than 0. You understand what I'm saying? So x minus 3, what's under the radical, must be bigger than or equal to what? 0. So now I can solve this, add 3 to both sides. So x must be bigger than or equal to 3. Do you see one that looks like that? Yeah, this is saying all real numbers as long as x is bigger than or equal to 3. So we're saying x must be bigger than or equal to 3. Pick me a number that's smaller than 3. 1. Can you plug 1 in? What's 1 minus 3?
Negative 2.
And you can't take the square root of negative 2, can you? And so that makes sense, doesn't it? As long as you put in a number equal to or bigger than 3, you'll get a what? So we said if you plug any number in that's equal to or bigger than 3, the function will provide you with an output. Okay, so in this case, we have two radicals. And we know that what's under the radical must be greater than or equal to 0. So I'm going to write what's under both radicals, 15 minus x, and I know that it must be greater than or equal to 0. And I'm going to write what's under the other radical, x minus 7, and I know that it must be greater than or equal to 0. And then I'm going to solve both of these. So I'll add x to both sides, and so I have 15 is greater than or equal to x. So if I want to write the x first, look at what n the x is on the inequality. The x is on the small side, right? And so when I rewrite it, x must be less than or equal to 15, right? 15 is on the large end of the inequality, so when I rewrite it, 15 must remain on the large end. Okay, now let's look at our other restriction. I'll add 7 on both sides, and so I'm saying x must also be greater than or equal to 7. Okay, and so I'm saying x must be, right here, I'm saying x must be smaller than 15. Right? Or equal to it. And right here I'm saying x must be bigger than 7. Right? So it has to be bigger than 7 and smaller than 15. Now which of these means smaller than 15 and bigger than 7. So the first one is the answer. Okay, now there's a mistake I made calculating it. In this case, x minus 7 must only be bigger than 0. It can't be equal to it. Because if it's equal to 0, then I'd be dividing by what? I'd be dividing by 0, wouldn't I? And so let's say I plug 7 into the function. I'd have the square root of 15 minus 7 over the square root of 7 minus 7. And so that'd give me the square root of 8 over the square root of 0. Well, what's the square root of 0? So I'd have the square root of 8 divided by 0. Type that in your calculator. The square root of 8 divided by 0. And so the reason why this is the answer, why it's not equal to right here, is because x must be not greater than or equal to 7. X just must be greater than 7. If it's equal to it, then you get an undefined because there's a 0 in the denominator.